thousands of years, you've looked at it. A calm, silent, and dead world, our loyal neighbour shining in the night. But we were completely wrong. When the Artemis II crew arrived, that peaceful view was shattered suddenly, because yes, the moon wasn't a cemetery. It was a firing range. In just a few hours, they witnessed 6 massive explosions. These were rocks slamming into the surface at 40,000 miles per hour, each one hot enough to melt steel. For 40 minutes, with all communication to Earth cut off, the astronauts watched this hell unfold. But that wasn't the most terrifying part. The real horror was realizing this bombardment never stops. If this savage face of our closest neighbor sends a shiver down your spine, like this video doesn't subscribe to the channel, key because soon every belief you have about the moon is about to be shattered. Are you ready? Let's begin. For years, we thought the moon was a silent, calm, and dead world, a silver disk, a faithful companion, hanging in the night sky. But this view we thought was unchanging was actually hiding an incredible violence. So, when the Artemis II crew passed behind that silver disk, they confronted a completely different reality. In that absolute silence, light flashed 6 times on the far side of the moon, 6 separate explosions. And yet, these explosions were just the opening act, in a terrifying truth that would change everything we knew about the moon. What were these explosions exactly? April 6th, 2026. The Orion spacecraft was gliding approximately 6,500 kilometers above the lunar surface. Everything was pitch black. Then, it happened suddenly. A point of light appeared on the surface, a sharp flash, lasting less than a second, and then it was gone. Commander Reed Wiseman was the first to see the explosion. But this was only the beginning. Because throughout that night, a total of 6 more confirmed impacts occurred. These were detonations caused by rocks from deep space, striking the lunar surface at speeds exceeding 64,000 kilometers per hour. These impacts were so violent, they produced flashes of light bright enough to be seen with the naked eye from thousands of kilometers away. 2 of the explosions happened at the most critical moment during the communication blackout. At that time, Orion was behind the moon, and all radio contact with Earth was severed. So only 4 humans witnessed the 2 flashes seen by Canadian astronaut Jeremy Hansen. 4 people watching explosions on a dead world, and they had no way of telling anyone. But the truly astonishing thing wasn't the existence of these explosions, because for scientists, this wasn't a surprise. What was truly shocking was how common they were. The moon is not a silent place. The moon is a target, a firing range. This is the moon's most fundamental and terrifying truth. It has no atmosphere. So, it has no shield to protect it, no defense whatsoever. It is completely naked against the constant bombardment of the solar system. NASA's Meteoroid Environment Office has been systematically monitoring the moon since 2005 to put this reality into numbers. Using twin telescopes at the Marshall Space Flight Center in Alabama, they have recorded over 443 potential impact flash events to date. The European Space Agency conducted a program called NELIOTA, using a 1.2-meter telescope in Greece. This program detected 192 confirmed lunar impact flashes between 2017 and 2023. But these numbers only represent what we can see from Earth. The real math is far more staggering. According to NELIOTA data, under normal conditions, the entire lunar surface is hit by about 7.4 meteors per hour. During meteor showers, this number jumps to 12.6 per hour. Most of the impacting rocks are small. Between 75 and 80% of them have a mass under 200 grams. Their radius is less than 3 centimeters. They're pebbles you might kick aside on a walk. But those pebbles are traveling at speeds ranging from 20 to 72 kilometers per second. That's 45,000 to 160,000 miles per hour. At these speeds, a rock the size of a golf ball carries the energy of a small bomb. It hits the surface, vaporizes itself and the surrounding soil, creates a crater several meters wide, and produces a flash of light reaching a temperature between 2,400 and 4,500 Kelvin. That temperature is hot enough to melt steel. Because, on Earth, the atmosphere burns up the vast majority of this space debris before it ever hits the ground. But, on the Moon, every single one reaches its target. Every grain of sand, every pebble, every rock, no friction, no burn-up, no warning. Just impact. So what does this constant bombardment mean for us, as we plan to return to the Moon and stay there? Do you see? Because NASA isn't just visiting the Moon, it's planning to go back and stay permanently. Artemis 3 will land astronauts on the lunar surface. Artemis 4 will build a space station in lunar orbit. Future missions aim to establish a permanent human presence on the Moon, a base, a habitat. But every one of these plans has to account for the fact that the Moon is constantly being hit. NELIOTA calculated these probabilities. The chance of a structure smaller than 400 square meters on the lunar surface being hit by a detectable meteor over 10 years is 2.9 in 100,000. That might sound small, but scale it up. The probability of a larger complex of 8,000 square meters being hit rises to 0.9% in a worst-case scenario. You are a satellite the size of the International Space Station in lunar orbit has a 1 to 2% chance of collision over a period of 5 years or more. And these numbers only include meteors large enough to be detected from Earth. Micrometeorites, those too small to cause a visible flash, are completely outside this calculation. There are millions of them. For an astronaut on a spacewalk on the lunar surface, a coin-sized rock moving at 40 kilometers per second is a projectile that no current spacesuit on Earth or in space is designed to stop. Mission pilot Victor Glover put it simply: humans probably did not evolve to see what we saw tonight. But the explosions were not the only terrifying thing the Artemis 2 crew saw that night. Because during that 40-minute communication blackout, as Orion disappeared behind the far side of the Moon and all radio contact with Earth was lost, the astronauts were utterly alone. More alone than any human in history. And in that silence, what they witnessed on the far side of the Moon was unlike anything they had been trained for. The colors were wrong, the terrain was alien, the silence, and what they witnessed within that silence takes us to the next stop on our journey. Because the far side of the Moon is a two-faced world. Because the far side of the Moon is not the Moon we know. When they arrived there, what the astronauts encountered didn't match any map, any photograph they had seen in training. And at the heart of this difference lay one of the most profound moments of loneliness in human history. A total communication blackout. April 6th, 2026, 1844 Eastern Time. The Orion spacecraft glided behind the Moon. One moment, NASA's Deep Space Network, a collection of giant antenna stations in California, Spain, and Australia, was tracking the crew, receiving telemetry, monitoring life support systems. The next moment, there was only silence. The massive bulk of the Moon blocked every radio signal, every stream of data. The screens at Mission Control in Houston went dark. Flight Director Judd Freeling had warned everyone this would happen. But physics doesn't talk back. So, for 40 minutes, no one on Earth could do anything but wait. The crew had been briefed, they had trained for this, and they knew the blackout was coming. But there's a world of difference between knowing something intellectually and experiencing it with your body. Because what they went through in those 40 minutes was something no simulation could have prepared them for. They experienced absolute isolation. This wasn't the loneliness of losing your cell signal on a desolate road. This was a total disconnection. There was no one to call, no one to reach, nothing. Just 4 human beings, sealed inside a capsule the size of a large SUV, gliding behind the Moon, with no line of sight to Earth. But they didn't just wait during this silence. They watched the Earth disappear. It's called Earthset. Just as the sun rises and sets from our perspective, for someone in lunar orbit, the Earth itself rises and sets. So, as Orion passed behind the far side, the crew watched their own home planet drop below the lunar horizon and vanish. One moment, Earth was there, a bright blue marble hanging in the black. The next, it was gone, hidden behind 6,500 kilometers of lunar rock. the only universe every human had ever known, swallowed by the edge of the moon. Mission specialist Christina Koch later spoke about this moment. But she didn't talk about science. She didn't talk about observations. She talked about seeing Earth again, which shows just how significant those 40 minutes without it were. The absence of Earth wasn't just visual, it was psychological, existential. But this profound loneliness unveiled one of the moon's greatest secrets. When the astronauts emerged from the blackout, they didn't just have impact reports. What they described about the face of the moon that doesn't face us forced scientists to rethink everything they thought they knew. Because that face looked nothing like the photographs they had studied. Why does the moon have two faces? The dark patches you see when you look from Earth are called Maria. These dark regions are ancient lava flows that spread across the surface billions of years ago, solidifying into smooth, dark sheets. 31% of the near side, almost a third, is covered by these volcanic plains. But less than 1% of the far side is. That side is a pale, ancient highland terrain, battered with crater upon crater. No lava plains, no dark seas, just a surface that has been beaten for 4.5 billion years without any volcanic resurfacing. This difference isn't just cosmetic, it runs literally deep. Because the crust of the far side is up to 20 kilometers thicker than the crust of the near side. This extra thickness meant that when asteroids hit the far side and cracked the crust, the magma underneath couldn't easily rise to the surface. The cracks didn't go deep enough. On the near side, however, the thinner crust cracked completely, and molten rock flooded the basins, creating the dark plains we see today. But why is the crust on one side thicker than the other? This is where the mystery deepens. The near side of the moon contains a geological region called the Procellarum creep terrain. Creep stands for potassium, rare earth elements, and phosphorus. This region is enriched with radioactive elements that produce heat as they decay, namely uranium, thorium, and potassium. This means there's a radioactive furnace that has been burning inside the moon for billions of years. This furnace fueled the volcanic activity on the near side. It kept the interior hot. It powered the eruptions that filled the basins. So, while the near side was geologically active, the far side remained cold and quiet. A study published in the journal Nature in 2025 confirmed this. By measuring how the moon slightly deforms in response to Earth's gravity, they determined that the mantle of the near side is measurably hotter than the mantle of the far side. The difference wasn't on the surface, it was baked into the moon's interior. And China's Chang'e 6 mission took this research even further. The mission collected the first ever samples from the far side of the moon, and what they found was stunning. The far side lavas that managed to reach the surface formed at about 1,100 degrees Celsius. This was roughly 100 degrees Celsius cooler than the basalts on the near side. This temperature difference shaped everything. So how did this asymmetry begin in the first place? Why did one hemisphere get enriched with radioactive elements while the other did not? The answer may lie in the most violent event in the moon's history, the one that created it. About 4.5 billion years ago, a Mars-sized body named Theia collided with the primordial Earth. The impact was so violent, it vaporized a significant portion of both bodies and threw a cloud of molten debris into orbit around the Earth. That debris coalesced and cooled to become the moon. And in those first moments, the radioactive elements may have concentrated on one side. From that moment on, the moon's fate was sealed. It was with all this background knowledge that the Artemis II crew went behind the moon. The explosions they saw were proof of the moon's vulnerability. The absolute silence they experienced was a measure of its isolation. And the two-faced world they witnessed was the result of a chemical roll of the dice, cast billions of years ago. But what did all these theories and data look like from the window of that tiny capsule? What were the actual findings the astronauts saw with their own eyes? Because, when the astronauts emerged from the blackout, they didn't just have impact reports. What they described about the far side of the moon forced scientists to rethink everything they thought they knew. Because that face looked nothing like the photographs they had studied, and the story of that face was a two-faced world. And that story began with colours, the wrong colours. The theories were over, the maps were set aside. Now there was only the raw truth outside the window, and the first shock came from the most basic truth we knew. The moon wasn't grey. It never was. This was not the moon we learned about in school. This was not the pale, monochromatic world from the photographs. When Christina Koch's voice came over the radio, scientists held their breath. "The more I look at the moon," she said, "the more brown it looks." But this was only the beginning, because the crew began describing shades of brown and blue, greenish hues in the highlands, and subtle tonal differences that changed depending on the angle of the light. This revealed a mineral composition that a satellite image could never capture. How was this possible? Because, while 31% of the near side is covered by dark lava plains called Maria, only 1% of the far side has these features. So, the far side was mostly pale, ancient highland rock, battered for billions of years. This was geology reflected on the surface. China's Chang'e 6 mission had proven that far-side lavas formed at around 1,100 degrees Celsius, about 100 degrees Celsius cooler than near-side lavas. This meant different minerals, different crystal structures, and ultimately different colours. But having this knowledge didn't lessen the shock of seeing it with your own eyes. The story we had been told for 50 years was wrong. The moon wasn't colourless, we were just looking at the wrong side. But then they reached the terminator. That sharp line where light meets darkness, and what they saw was far more jarring than colours. Victor Glover's voice was filled with astonishment. "We've crossed into science fiction," he said, because that line, which appears from Earth as a smooth curve, was a hellish landscape when viewed from lunar orbit. "Incredibly rugged," added Jeremy Hansen. The crew saw small islands of terrain completely surrounded by darkness. These were mountain peaks and crater rims, catching the last rays of sunlight while the valleys around them had already plunged into night. The landscape looked shattered, broken, alien. The sunlight was hitting the surface at an almost parallel angle. So, every ridge, every hill, every crater rim cast immense, long shadows across the landscape. These shadows revealed micro-ridges, subtle fractures, and minor changes in elevation that were normally invisible. The astronauts were seeing something that the Apollo missions at an altitude of 96 kilometers could never see. Because yes, they were looking from an altitude of about 6,500 kilometers from a completely different perspective. And this perspective dropped the moon's smooth mask. It revealed the true chaos underneath. The Terminator was a revealer, and what it revealed was that the moon was not a peaceful place, but a world violently shaped, beaten and shattered. The landscape they saw was on no map. It was shown in no simulation. This was the first time the human eye had grasped what a camera could never convey, the three-dimensional horror of it all. And just when things couldn't get any stranger, the true impossibility arrived. There was snow on the moon. Victor Glover reported that some mountain peaks near the Terminator were so bright, they looked as if they were covered in snow. This shouldn't be. This was impossible. Of course, it wasn't snow. There couldn't be that amount of solid water on the moon's surface, especially in a place receiving direct sunlight. The temperatures there would instantly vaporize any ice. But the image was there, before the astronauts' eyes, a landscape that looked indisputably like a snow-capped mountain range on Earth. So what was it? This was likely fresh rock that hadn't been exposed to space weathering. A place where a meteorite, striking at 40 kilometers per second, had exposed brighter material from beneath the surface, pure rock, not darkened by millions of years of solar wind and micrometeorite bombardment. This rock was reflecting the low-angle sunlight with extraordinary brightness. But this logical explanation doesn't diminish the shock of the moment, because on one hand, there were pitch-black valleys where temperatures could plummet to minus 230 degrees Celsius. On the other, these incredibly white peaks contrasting against them. This visual contrast was so extreme, the brain had only one reference to process it: snow. The astronauts were seeing snow, even though they knew it couldn't physically be there. This was the ultimate proof of how alien the moon is, and how inadequate our expectations are. These findings were like pieces of a puzzle. The wrong colours, a shattered landscape, and impossible snow. They all screamed how different a place the moon is from the face it shows us. But these were just visual shocks, just what was on the surface. And the strangest, most inhuman phenomenon the Artemis II crew faced wasn't a landscape outside their eyes, it was inside their eyes. Because, in absolute darkness, even with their eyes closed, they continued to see, and what they saw was a bombardment. But this bombardment wasn't on the surface, it was inside their own heads. This phenomenon first began on Apollo 11. Buzz Aldrin was in the command module, in the dark, trying to sleep with his eyes closed. But he saw a flash of light, not from the window, not a warning light, inside his eye. A brief streak of white light that appeared and vanished in less than a second. He opened his eyes. The cabin was dark. Then he closed them again. Another flash. This was Iem Pos Psi Bell. But every subsequent Apollo crew reported the same phenomenon, from Apollo 12 to 17. Every astronaut who travelled beyond Earth orbit and spent time in darkness saw these flashes. Some were dots, like a camera flash going off behind the eyelid. Some were star-like. Others were streaks that left a trail across their field of vision and disappeared. The astronauts were not hallucinating. Because the explanation was far stranger. They were being shot with cosmic rays, high-energy particles originating from supernova, black holes, the shock waves of colliding galaxies. These particles hurtle across the universe at nearly the speed of light. On Earth, we are protected by the planet's magnetic field and atmosphere. But on the Moon and in deep space, there is no protection. So, those particles pass through the walls of the spacecraft. They pass through the astronauts' bodies, and some of them pass through their eyes. When a particle passes through the vitreous humor of the eye, exceeding the local speed of light in that medium, it produces a short flash of bluish light called Cherenkov radiation. Or the particle strikes the retinal cells directly, causing them to fire as if they'd been hit by light. On average, the Apollo astronauts reported seeing a flash every 2.9 minutes. This was the visual evidence of a bombardment passing through their heads. Each flash meant a cosmic ray particle had just passed through the astronaut's head at nearly the speed of the light, depositing energy and continuing on its way. And this was just the beginning. But the Moon's secrets weren't limited to invisible particles. Some were painted across the surface like a giant brushstroke. One of the 35 targets the crew observed was a feature that has puzzled scientists since the Renaissance. Its name is Rhina Gamma. It's located in Oceanus Procellarum, the largest dark lava plain on the near side, and it's unlike anything else on the Moon. Because Rhina Gamma is a bright, tadpole-shaped marking on the surface. It was first noticed in the 1600s with primitive telescopes. It has been studied and debated ever since. It's not a crater, it's not lava flow. It's a pattern of brightness on the surface with no obvious geological origin. It almost looks as if someone painted on the dark basalt with a pale brushstroke. How could this be? The answer lies in one of the Moon's strangest features. Rhina Gamma isn't just a bright spot. It sits directly over one of the strongest magnetic anomalies on the Moon. This is where the story gets even weirder. The Moon no longer has a global magnetic field. It died billions of years ago. So, the Moon should be magnetically naked. But it's not. There are dozens of local magnetic pockets scattered across its surface. Small regions where the surface rocks carry a magnetic signature, like a tattoo left behind by a field that no longer exists. The strength of these anomalies is very weak compared to Earth's field. Only a few hundred nanoteslas. Yeah, Earth's is about 50,000 nanoteslas, but they are there, and most of the bright swirls on the Moon, including Rhina Gamma, are located directly over these magnetic fields. The leading theory is called the magnetic sunscreen hypothesis. The anomaly deflects some of the incoming solar wind particles, shielding the surface beneath it from space weathering. So, that area remains brighter. But this raises a deeper question. How did these magnetic tattoos get there in the first place? There are three main explanations for the origin of these magnetic ghosts. First, comet impacts. When a comet strikes the Moon, it can leave behind magnetized material. Second, giant basin-forming impacts. When a massive asteroid hit the Moon while its ancient magnetic field was still active, it could have thrown iron-rich debris onto the surface. As this debris cooled, it could have locked in the magnetic signature. But the third explanation is the most compelling. It suggests that the cooling of high titanium magma underground could produce a magnetism strong enough to explain the observed anomalies. In this model, the magnetic anomalies aren't on the surface, but are underground magnets buried deep in the crust. So Reiner Gamma isn't just a surface stain, it's a ghost projected onto the surface of a dynamo that died billions of years ago in a strange geology underground. NASA had planned a mission called Lunar Vertex to investigate this region up close, but that mission was postponed. So, the mystery of that swirl remains unsolved for now. A message, written on the surface of the moon in magnetic ink, and scientists are still learning to read it. Or explosions, the wrong colours, peaks that look like snow, lights inside their heads, and magnetic tattoos. The Artemis II crew saw firsthand, beyond theories and numbers, just how strange, how active, and how mysterious the moon really is. But all these findings bring up a more fundamental question. How did they see all this? What is the difference between a human eye and a satellite's camera? Why did NASA send 4 people, stretching a t-shirt over a window to look into the darkness, instead of a multi-billion-dollar robot? This is the story of how the human eye does something a machine can never do. And that story is a bombardment. But how exactly does the mechanism behind these shocking discoveries work? Why can a human see things that a multi-billion-dollar satellite cannot? It's time to slow down and delve into the technical details of this question. Because the answer lies not just in biology and physics, but in the simplicity of a sandbox and a t-shirt. The Artemis II mission had 10 key scientific objectives, but one of them had to do not with sensors or spectroscopes, but with the human eye. The first of these mechanisms lies in the fundamental difference between the human eye and a satellite camera. You can think of a satellite as a piano with only specific keys. Satellites like the Lunar Reconnaissance Orbiter have mapped the moon in extraordinary detail since 2009. We have high-resolution images of almost every square meter of the surface. But these cameras record light in specific wavelength bands, fixed frequencies. It's like a piano that can only play the notes C, G, and E in the next octave. It misses the notes in between. The human eye doesn't work like that. Because the human eye perceives a continuous spectrum. It's not a piano, it's a full orchestra. It can detect the subtle color transitions that fall between the wavelength bands the satellite was designed to measure. So, the crew seeing brown, blue, and greenish hues means these colors fell into the satellite's blind spots. They were there. We just weren't listening with the right instrument. Artemis II lunar science lead Kelsey Young sums it up perfectly. The human eye, coupled with a well-trained brain, can make nuanced color observations in literally the blink of an eye. That simple sentence contains the entire argument for why we send people. Cameras record specific wavelengths, like 700 nanometers or 550 nanometers, but a slight orange hue at 612 nanometers. If that doesn't fall into one of the camera's preset bands, it simply doesn't exist for the software. It's either rounded to the color of the neighboring band or lost entirely. But the human eye and brain instantly catch that subtle difference. This is why the colors reported by the astronauts are revolutionary for understanding lunar geology. Because every mineral reflects light slightly differently. Different colors mean different minerals, and that is vital for mapping the moon's resources, but it's not just about color perception. The second and perhaps more important mechanism was the constantly changing angle of illumination. Kelsey Young used a simple analogy to explain this. Imagine a sandbox. You shine a flashlight on it. If you hold the flashlight directly overhead, you only see the color and brightness of the sand. But if you hold the flashlight from the side, at a low angle, the tiny shadows cast by each grain of sand suddenly appear. You understand the texture and morphology, whether the surface is rough or smooth. An orbiting satellite captures the surface under a single lighting condition with each pass. It's like a single photo of the sandbox taken from above. However, the Artemis II crew saw the same features on the lunar surface under constantly changing illumination. As Orion moved at an altitude of about 6,500 kilometers, the angle of the sun was constantly changing. The same crater looked completely different than it did a minute before. This gave them something a single photograph could never give, a dynamic perspective. This effect peaked especially as they approached the terminator, the line between light and dark. There, sunlight was coming in almost parallel to the surface. This caused even the smallest hills to cast shadows kilometers long. This was the impossibly rugged landscape that Victor Glover described as crossing into science fiction. Those long shadows revealed small ridges, fractures, and elevation differences that were lost in the flat, top-down images from satellites. It's the difference between looking at a two-dimensional map of the moon's surface and walking in that terrain in 3 dimensions. A satellite tells you there is a crater there. A human eye under changing illumination tells you how sharp the rim of that crater is, how deep the shadows inside are, and how its walls have eroded. This is the difference between collecting data and understanding it. The third key mechanism is the parallax effect and 3-dimensional perception. This is something your brain does automatically when you look out the window of a moving car. The trees near you rush past, while the distant mountains remain almost stationary. Your brain uses this difference in motion to understand how far away objects are. This is parallax. Now, scale this up to the moon. As the Artemis II crew passed by the giant Oriental Basin, which is nearly 930 kilometers wide, the spacecraft was moving at thousands of kilometers per hour. So, the crew observed the basin from constantly changing angles. Within 15 minutes, Orion's position had changed by hundreds of kilometers. This created a massive baseline for the brain to construct a 3-dimensional image. This is something a single orbital photograph could never provide. A photo, no matter how high resolution, is flat. But the crew's brain combined these constantly changing images to mentally construct the true, just 3-dimensional structure of the Oriental Basin. This is why they perceived the 3 massive nested mountain rings, the Cordillera, Outer Rook, and Inner Rook mountains, not just as circles on a map, but as massive structures with real depth. And similarly, when they compared the much older and more eroded Herschel crater with Oriental, this 3D perception became visual proof of geologic time. They concretely saw how billions of years of bombardment had softened and degraded a crater. This is the difference between reading a geology textbook and standing inside that geological structure. NASA sent the human eye there for this specific reason. Because even the most advanced computer cannot yet compete with the pattern, recognition, and 3D modeling ability of a human brain, fine-tuned by hundreds of millions of years of evolution. These 3 mechanisms, full-spectrum color perception, texture, revelation from changing illumination, and 3D vision through parallax, formed the basis of Artemis II's scientific success. This was the technical explanation for why the human eye is superior to a machine, but there's also the human factor in this equation, those unpredictable, messy, and entirely human details, from hanging a t-shirt on a window to the astronaut's eyes getting tired. So how did this human element shape the scientific process? And most importantly, what happened when they set science aside for a moment and were just human? Because the most unforgettable moment of the mission could not be measured by any technical data. And this brings us to the 4th and most important mechanism, the human being itself, the place where the sterile laboratory of science meets the messy, unpredictable, and fascinating reality of being human. This mechanism begins with a t-shirt, and to be able to perceive those subtle color differences on the moon's surface, the crew's eyes needed to be fully adapted to the dark. But the inside of the Orion capsule was filled with indicator lights and tablet screens. So, the crew found an extremely simple solution. They stretched a t-shirt over one of the windows to block the light from inside. On a multi-billion-dollar space mission, one of the most critical observations was being made with the help of a t-shirt. But the human factor didn't end there. It's because that t-shirt caused condensation to form on the window due to the moisture inside the capsule. This required the crew to use a condensation hose to dry the fog. This is a problem you would never encounter on a robotic mission. Robots don't get tired, they don't sweat, they don't breathe, but humans do. Or Victor Glover noted how tiring it was for his eyes to switch between the dark cabin, the dim tablet screen, and the bright lunar surface. "It's a very fatiguing event for the eyes," he said. "I can feel my eyes adjusting when I come back into the cabin after looking out the window. This is the human factor of doing science in a small capsule. 400,000 kilometers from home, messy, real, and full of valuable data that would never appear in a robot's report. This is why NASA scientists had the astronauts work in two-person teams. While 2 astronauts made observations at the windows for 55 to 85 minutes, the other 2 communicated with mission control, exercised, or ate. This wasn't just for efficiency, but to understand the limits of human endurance. A robot can work forever until its battery runs out, but a human works only until the next break time. And sometimes, in those breaks, the most unexpected science emerges. But the moment this human mechanism was most powerful was when emotions, not data, took center stage. This is where science turns into poetry. A robot can catalogue thousands of craters on the surface. It can precisely measure their diameter, depth, and age. But a robot will never name a crater after the spouse it has lost. That is something only a human can do. And when Jeremy Hansen's voice reached Earth from lunar orbit that day, it showed everyone the power of this mechanism. The crew had identified 2 fresh, previously unnamed craters. They wanted to name the first one Integrity after their spacecraft, but the second one was different. Hansen described the crater's location. Then he spoke the words that froze mission control. It's a bright spot on the moon, and we'd like to call it Carol. Carol Taylor Wiseman was the wife of Commander Reed Wiseman. She had passed away from cancer in 2020 at the age of 46. As Hansen spoke, Wiseman placed his hand on his shoulder. His eyes were full. Then the 2 men embraced. Then Koch and Glover joined them. The 4 astronauts hugged each other in zero gravity, wiping away tears. In that moment, mission control in Houston fell silent. This was not a data point. This was humanity itself. And this moment accomplished more than any of the mission's scientific objectives. For millions of people, the Artemis II mission was no longer just a spaceflight. It had become a story of love, loss, and remembrance. And this is the mechanism of public engagement, of inspiration, and of human connection. A robot cannot justify a multi-billion-dollar budget. But a man who names a crater on the moon in memory of his wife can. Because it reminds us why we go to space, not just to understand what we are, but to understand who we are. And this process of understanding who we are culminates in another powerful psychological mechanism, the overview effect. The term was coined by space philosopher Frank White in 1987 to describe the cognitive shift astronauts experience when they see the Earth from space. It's not just a feeling of awe, it is a fundamental change in perspective. You can think of it as the difference between looking at a map of your city and looking at that city from an airplane. The map gives you the names and layout of the streets, but from the plane, you see that the city is a living, breathing organism, how all those separate parts form a single whole. This is the overview effect, but on a cosmic scale. When astronauts look at Earth, borders disappear, conflicts shrink. The planet appears as what it is, a single system, a single organism, a single home shared by all living things. The crew of Apollo 8 were the first to experience this in 1968. The Earthrise photograph they took helped ignite the environmental movement, because it showed humanity its own fragility in a way that no speech or statistic ever could. The Artemis II crew experienced the same shift. Victor Glover's message at that moment was a summary of this effect. Trust us. You look great. You look beautiful. And you look like one thing. Homo sapiens. That's all of us. This is a discovery beyond science. This is the argument for going to space not for resources or geopolitics, but for perspective. It's to remember that down on the surface, we're all standing on the same rock. This mechanism produces not data, but wisdom. And that wisdom is perhaps a mission's most enduring legacy. The technical superiority of the human eye, the messy reality of the human factor, and the profound wisdom of the overview effect. These were the multi-layered mechanisms behind why NASA sent 4 humans to the moon instead of a robot. To collect data, to understand, and to transform that understanding into a story that would inspire the rest of humanity. But all these technical and human mechanisms had not prepared the crew for what they had seen up to that point. because their orbit was carrying them to that single point where the sun, the moon, and the spacecraft would come into perfect alignment. And at that point, what they were about to witness was both an end and a beginning. The most extraordinary, most mind-bending spectacle was still ahead of them, a miracle that lasted 57 minutes. The moment they watched the death and rebirth of the sun. The moment they watched the death and rebirth of the sun. And now, the real miracle begins. The tempo quickens, breaths are held. Because everything we've talked about so far was just a preparation. The explosions, the wrong colours, the terror of the Terminator. These were just the opening of the curtain. But now, the main event begins. This is the climax of the video, the journey to the farthest point in human history. Records broken, paradigms shattered, and mind-bending sights no human has ever witnessed before. Fasten your seatbelts. Because we are now reaching maximum velocity, and the first record was the defeat of a ghost. The record was broken. It's that simple. The record of Apollo 13, that legendary limit, unbroken for 53 years, it was gone. On April 6th, 2026, at exactly 1907 Eastern Time, the Orion capsule reached a distance of 407,522 kilometers from Earth. Apollo 13's record was 400,171 kilometers. That means they went a full 7,351 kilometers farther. That's a greater distance than between Istanbul and Beijing. In that moment, they were farther away than any human who's ever lived or died. They became the loneliest, most distant pioneers of the human species. But how was this record possible? Because Orion followed a different trajectory than Apollo. It made a pass around the moon at a higher altitude, about 6,500 kilometers from the surface. This free return trajectory gave them a greater swing-by effect than Apollo 13's emergency route. So, when that moment came, there was no round of applause in mission control. Because this record wasn't a destination, it was a waypoint. The words Jeremy Hansen spoke at that moment summed it all up. We are challenging this generation and the next to ensure that this record does not stand for long. This wasn't a celebration, it was a passing of the torch. It was saying, we came here, now you go farther. This was the clearest, most staggering declaration that humanity's journey into space was just beginning again. And they did it in silence, knowing they had broken the record. But the next record, no sensor could measure that one. Because this wasn't about physics, it was about the human heart. At the farthest point in history, the most human moment occurred, and this too was a record. No human had ever before named a celestial body in memory of their lost spouse. 400,000 kilometers from home. This was a first in history. This was Carol's moment. The wife of Commander Reed Wiseman lost to cancer at the age of 46. The crew had found two fresh, unnamed craters, but the choice of Carol's crater was no coincidence. That crater was located on the border between the near and far sides of the moon. Near the crater Glushko, it was a bright spot, visible from Earth at certain points in the moon's libration. A bright spot on the moon, Hansen said, and in that moment, Wiseman's eyes filled with tears. The four astronauts hugged each other in zero gravity. This was not something NASA had planned. This was not a procedure. This was humanity. And in that moment, mission control in Houston fell silent. Millions of dollars of equipment, hundreds of experts. They all fell silent and witnessed the sanctity of that moment. The internet exploded. One commenter wrote, "Turns out Carol was loved to the moon and back, literally." Another said, "Their babies can look up at the night sky and see their mother." This was the greatest proof of how a space mission can instantly become a universal human story. This was the moment the cold logic of science melted in the warmth of grief and love. And this may be Artemis II's most enduring record, showing that even at its farthest point, humanity does not leave its heart at home. And then, history repeated itself, but not like a repetition, like an echo, stronger, clearer. 7:24. Orion emerged from behind the moon after the 40-minute communication blackout, and outside the window, there it was, Earthrise. that iconic photograph taken by Apollo 8 on Christmas of 1968. That moment etched into humanity's collective consciousness. And now, more than 53 years later, it was being experienced live for a new generation. But this time, it was different. Orion was much farther away than Apollo. So, the Earth looked smaller, more fragile, a bright blue and white jewel hanging in the absolute blackness. In that moment, the overview effect hit with its full force. Christina Koch described the moment as humbling, and Victor Glover was perhaps the one who best summarized the unifying power of that moment. "You look like one thing," he said, looking at Earth. "Homo sapiens. That's all of us. It doesn't matter where you're from or what you look like. We are all one people." This was a call for peace, from 400,000 kilometers away. This was the 21st century reflection of that first shock Bill Anders felt in 1968. "Yeah, we came all this way to explore the moon," Anders had said, "and the most important thing is that we discovered the Earth." The Artemis II crew discovered the same thing, but this time, they had the technology to share that discovery. They could share that moment with the entire planet simultaneously. And the Earth watched, holding its breath, at its own small, fragile, and incredibly precious portrait. But this emotional moment was just a precursor to the next, mind-bending event. And then, that moment came. The most incredible, the most mind-bending, the most epic moment. A total solar eclipse on Earth. It lasts a few minutes. People travel thousands of kilometers for those few minutes. They cry, they scream, their lives are changed. Now take that and multiply it by 30. Because what the Artemis II crew witnessed was an eclipse that lasted not minutes, but hours. April 6th, 2026, 2035. From Orion's perspective, the sun began to slide behind the moon, and then it disappeared completely, and the corona exploded, the sun's multi-million-degree outer atmosphere, those ghostly white flames normally invisible due to the sun's own brightness. Now, they shimmered like a crown around the black disk of the moon. "Indescribable," came Reed Wiseman's voice. "Our brains aren't processing this image. It's absolutely surreal." Victor Glover added, "Humans probably did not evolve to see what we're seeing. But what made this eclipse unprecedented in history was its duration. The total eclipse lasted from 2035 to 2132, a full 57 minutes, almost an hour. How was this possible? Because, unlike an observer on Earth, Orion wasn't passing through the moon's shadow. It was moving with it. They were virtually surfing on the edge of the shadow. This was an experience no human had ever had before. Glover compared the moment to the 42 billion candela spotlight on top of the Luxor Hotel in Las Vegas. "This," he said, "looks like what that spotlight wants to be when it grows up." But the biggest shock was not the darkness. The dark side of the moon should have been pitch black, but it wasn't. It was glowing. It shimmered with a pale, ghostly light, and that light wasn't coming from the sun. It was coming from us, from Earth. The daylight side of our planet was reflecting so much sunlight into space that that light traveled 400,000 kilometers and illuminated the night side of the moon. This is called Earthshine, but the crew had never imagined that light would be so bright. "The Earth is so bright," Glover reported, "that we can see surface features on the night side." In that moment, the roles were reversed. Our small blue planet had become a beacon for its own moon, and 4 humans were witnessing a sight no one had ever seen before: the surface of another world, illuminated by the light of their own home. This was beyond science. This was poetry, and within that poetry lay an even deeper mystery. The miracle was not over. The real show was just beginning. The astronauts were witnessing something no human had ever seen during a solar eclipse. The solar system itself was transforming from a background decoration into the stage itself. This was the most unique, most unexpected astronomical observation in history. Because in that pitch, darkness, they suddenly appeared. 4 bright points, 4 planets, Venus, Mars, Saturn, and Mercury, all shining at the same time around the black silhouette of the moon. Normally, it's almost impossible to see planets near the sun, but for those 57 minutes, because the moon perfectly blocked the sun, The sky had darkened enough to reveal the inner orbits of the solar system. This was an observation that could never be made from Earth, because Earth's atmosphere scatters light and hides such faint points. But there, in that absolute vacuum, the planets shone like diamonds. But that wasn't all. Glover reported something else over the radio, and it shocked the scientists. They saw 2 meteors during the eclipse. But these were not impact flashes on the lunar surface. These were actual meteors, passing in front of the Orion capsule in the vacuum of space. 2 streaks of light, flashing for a moment, and then gone. How could this be possible? Nor these small pieces of debris either momentarily burned up by interacting with the tenuous solar environment, or simply reflected sunlight as they passed through the field of view. This is an incredibly rare event. Think about how vast an empty space is, and to see 2 through that tiny window in that brief moment. This was the most direct evidence of how dynamic, how alive, and how dirty the solar system really is. The astronauts weren't just looking at the moon, they were watching the workings of the solar system raw and unfiltered in real time. This was an unplanned scientific bonus, and it turned the longest solar eclipse in history into the most productive, unplanned observation moment in history as well. But there were other ghosts the crew was looking for. These were lights far more elusive, far more mysterious than planets or meteors, the zodiacal light, and levitated lunar dust. These 2 phenomena are among the most challenging observational targets in the solar system, and the eclipse was the greatest opportunity in history to catch them. The zodiacal light is a faint glow created by sunlight reflecting off interplanetary dust particles. This dust fills the plane of the solar system, but it is so faint that it's barely discernible even on the darkest and clearest nights on Earth. Levitated lunar dust is even stranger. During the Apollo missions, astronauts noticed a mysterious glow along the lunar horizon at sunrise and sunset. Scientists believe this is microscopic dust particles, electrostatically charged by the sun's ultraviolet radiation and repelled from the surface. A cloud of dust, hovering just above the moon's surface, a ghost atmosphere. How could this be possible? The moon has no atmosphere, but the sun's radiation gives the dust grains on the surface a positive charge. Since the surface is also charged the same way, these grains repel each other, just like when you bring the same poles of 2 magnets together. So, these tiny dust particles levitate a few centimeters or meters above the surface. During the eclipse, with the sun blocked, it was hoped that these floating dust particles could be seen in silhouette against the faint corona light behind them. The Artemis II crew searched for these 2 ghostly glows. Whether they could definitively confirm them will be revealed when the data is analysed, but the search itself proves how important human spaceflight is. Because assay and noticing such fleeting, incredibly faint, and unexpected phenomena is the expertise of a well-trained and adapted human eye. A robot looks for what it's told to look for. But a human can notice something they weren't expecting. These deepest secrets of the moon could perhaps only be captured by a human in that perfect moment of darkness. And then, a moment came that was beyond all records, all scientific observations, all sights, a voice from the past, one of the most poignant, most powerful moments in history. Mission Control beamed a recording to Orion on the morning of the flyby. "Hello, Artemis II," the voice said. "This is Apollo astronaut Jim Lovell. Welcome to my old neighborhood." In that moment, time inside the Orion capsule stood still. This wasn't the voice of just any astronaut. This was the voice of a legend who had gone to the moon twice. One of the first humans to orbit the moon with Apollo 8 in 1968, and the commander who returned from the brink of disaster with Apollo 13 in 1970. This voice was the former holder of the 400,171-kilometer record that the Artemis II crew had just broken with 407,522 kilometers. And he had recorded this message just 2 months before his death in August 2025, at the age of 97. This was his last message. It was a bridge spanning from one generation to another, a voice that filled a 58-year gap. "It's a historic day, and I know how busy you're going to be," Lovell continued, "but don't forget to enjoy the view." That simple sentence contained over half a century of wisdom. Was enjoy the view, because that view is going to change you. This was the longest distance handshake in human history, and the Artemis II crew was carrying not just this voice, but the silk mission patch Lovell flew on Apollo 8. That patch was going to the moon for the second time, in different hands, but on the same journey. This was a continuity that science cannot measure. This was the legacy not of rockets or orbits, but of the human spirit. And as Jim Lovell's voice echoed in lunar orbit that day, it proved that this mission was not just made of metal and fuel, but also of memories, dreams, and a passion that has spanned generations. And the final act of that climax took place in Houston, on Earth, with a quiet, simple, but incredibly powerful action. Capsule communicator Jenny Gibbons' voice came over the radio, and she said that all the flight controllers in Houston had flipped their Artemis II mission patches over. One side of the patch showed Earth in the foreground, with the moon in the distance, symbolizing the departure. But now, everyone had flipped the patch. Now the moon was in the foreground and the Earth was behind it. "We are go for Earth," Gibbons said, "and we are ready to bring you home." In that moment, the perspective had shifted. The mission was complete. The target was no longer the moon, the target was home. That moment, that simple act, summarized the entire philosophy of the mission, that the real purpose of going to space is to be able to look back at Earth with new eyes. This was the overview effect transformed into a concrete action. This was the moment when a 10-day mission, a 7-hour flyby, and a 57-minute eclipse were crowned with a single symbolic gesture. This was the declaration that humanity's farthest journey was in fact the beginning of the journey home. Explosions, records, tears and eclipse, a voice from the past and the promise of return. These were the things Artemis II found behind the moon. But now, it's time to slow down, time to stop and think. All these records, all these tears, all these mind-bending sights, what do they mean for us, here, on that little blue planet? Is this just the story of a handful of astronauts, or is it all of our story? And now, it's time to stop and think. We're slowing down. Because guys, everything told so far was a story of what and how. What did they find? How did they find it? But the deepest question remains unanswered. Why? Why is this journey so important? These records, these tears, these mind-bending sights, what do they mean for us? The billions of people living here, on that little blue planet. Is this just the story of a handful of astronauts? Or is it the shared story of all of us, the human family? Now, it's time to go beyond science and numbers and dive into the philosophy of this journey. Because the greatest discovery we made behind the moon was perhaps ourselves. And this discovery is filled with a series of profound and unsettling paradoxes. The first of these is the paradox of distance and closeness. On one hand, there is the greatest physical distance in human history. 4 people went 407,522 kilometers away from Earth. This is a distance the mind cannot fathom. In that absolute silence, in the darkness of the communication blackout, in that moment when Earth disappeared below the horizon, they were the loneliest beings in the universe. This is a cosmic isolation. A void where no cry for help would be heard, no voice would reach. You, watching this video right now, may feel lonely, in your room, in a crowded city, even among your loved ones. But their loneliness was existential. They were literally disconnected from the rest of their species. This is the tragic truth of humanity's place in the universe. We are the inhabitants of a tiny island in the middle of a vast emptiness, and when we leave that island, we face an overwhelming loneliness. But, this is precisely where the miracle of the story begins, because we're at that very farthest, most lonely point, the most profound moments of intimacy in human history occurred. In that absolute silence, a man named a crater on the moon after the wife he had lost years ago. And in that moment, those 4 lonely souls became a single heart, hugging each other in zero gravity. In that void, the voice of a man who had made the same journey 58 years earlier, Jim Lovell, echoed. And when those 4 people looked out their windows, they saw not just the void, but the earthshine, illuminating their home. Distance did not sever them. On the contrary, it connected them to each other and to their home like never before. This is the great paradox. Sometimes, to truly see something, you have to go very far away from it. You know this too. Sometimes, to truly appreciate your family, as your city, as your life, you have to take a step away from it. Artemis 2 showed us that physical distance is not an obstacle to emotional closeness. On the contrary, it proved it can be a catalyst for it. No matter how far we go, we always carry our hearts with us, and that heart is an invisible string that connects us to one another. You are a part of that connection too. The second paradox is the paradox of time and the moment. On one hand, there is the unimaginable vastness of geological time. The astronauts looked at the Orientale Basin, formed 3.8 billion years ago. They witnessed a surface battered by meteorites for 4.5 billion years. These numbers are meaningless on the scale of a human lifespan. The average human life lasts about 80 years, roughly 30,000 days. The age of the moon is about 56 million times that lifespan. This is the tragic truth of humanity's place on the timeline of the universe. We are less than a blink of an eye. Our existence is like a single grain of sand in a cosmic hourglass. Our civilizations, our empires, our wars, our loves, they are all but a momentary wave in the vast ocean of geological time. The crater, Carol, will be there for millions of years after we are gone, but we will not be. This is that deep yet melancholic feeling that comes with existence, the awareness of our transience. But, again, that magic word, that brief moment changes everything. Because the Artemis 2 mission showed us that the value of a moment is measured not by its duration, but by its content. That 57-minute solar eclipse. That brief period of time contained more miracles than most people will encounter in a lifetime. That 2-minute Carol moment. That moment carried more meaning and emotion than billions of years of geological time. This is the great paradox of time. Eternity sometimes fits into the shortest of moments. Our power lies not in stopping time, but in filling those brief moments with meaning. Your time is also limited. Your days are also numbered. This may seem like a tragic truth, but it is also your greatest strength. Because it makes every moment precious, every sunset, every laugh, every hug. You, in that brief span of time, have the potential to touch eternity, just as those 4 astronauts did in those 57 minutes. They reminded us that it's not the quantity of time, but the quality that matters. And you too have the power to create your own moments, your own small eternities. The third and perhaps most unsettling paradox is the paradox of knowledge and mystery. On one hand, there is the immense scientific knowledge humanity has accumulated. Inside that capsule was centuries of knowledge of astronomy, physics, and geology. They knew about the moon's two-faced nature. They knew about the Carib terrain, impact physics, Cherenkov radiation. They had maps, models, expectations. We are a species that understands the universe. This is our greatest strength. With telescopes all over the world, with probes in space, with experiments in labs, we are solving the secrets of the universe one by one. This is the triumph of reason. But, when the Artemis 2 crew arrived at the moon, that triumph was replaced by a deep humility. Because nothing they saw matched their expectations. The colors were wrong. The Terminator was like science fiction. The mountain peaks looked impossibly snow-capped. This is the tragic truth of knowledge. The more we learn, the better we understand how little we know. As our ocean of knowledge grows, so does the shoreline of our ignorance. Every answer gives birth to 10 new questions, and this shows humanity's place in the face of the universe. We are curious children, wandering in the dark with a flashlight. As the area illuminated by our flashlight grows, we see more clearly how vast the darkness around us is. But this is also the most beautiful part of science. Its purpose is not to destroy mystery, but to find it. Our science is as much the art of asking better questions as it is the art of finding answers. The shock the astronauts experienced was not a failure. On the contrary, it was the greatest success. Because it meant that discovery was beginning again. It showed that the adventure continues. You experience this in your life too. You think you completely understand something, that you have mastered a subject. But then life shows you something you didn't know, an unexpected event, a new person, a different perspective, and in that moment, everything you thought you knew is shaken. This can be scary, but it is also exciting. Because the real adventure begins where the map ends. The Artemis II crew reached the end of the map, and they showed us just how strange, how beautiful, and how worthy of exploration that unknown land is. And there's distance and closeness, time and the moment, knowledge and mystery. These three paradoxes are the profound lessons the lunar journey has taught us about ourselves. But these lessons raise a bigger question. What will we do with this new perspective, this new understanding? Is this just a philosophical exercise, or is it a call to action? Because what we bring back from the journey is as important as the journey itself, and what the Artemis II crew brought home. And what the Artemis II crew brought home goes to the very heart of this question. Because this journey served not only as an exploration but also as a mirror. And what we saw in that mirror is our fourth and most fundamental paradox, the paradox of fragility and strength. On one hand, there is the absolute fragility of humanity and our planet. Apollo 8's Earthrise photograph slammed this reality in our faces in 1968. That small lonely marble hanging in a black void, a place where borders are invisible, wars are unnoticed, and all of human history has played out under that thin blue atmosphere. The Artemis II crew saw this fragility even more sharply, because they were farther away and the Earth looked smaller. This is the most poignant truth of humanity's place in the universe. We are fragile beings, living on an incredibly delicate biosphere, floating in a cosmic ocean. An asteroid impact, a supervolcano eruption, a climate crisis of our own making, all can upset this fragile balance. From that window, all our power, all our technology, all our civilization looked like a thin veneer on that blue glow. Fragile, unprotected, and extremely precious. But yeah, from the same window, the incredible strength and resilience of humanity was also seen. Those small, fragile beings were inside that capsule. They had understood the laws of physics that govern that void, and by using those laws instead of defying them, they had travelled 407,522 kilometres. This was the power of intelligence, the power of curiosity, the power of collaboration. That capsule was the result of the combined work, sweat and genius of thousands of people over decades. This is the great paradox. We may be one of the weakest forces in the universe physically, but our mind has made us beings capable of understanding the universe itself. Our power to understand our fragility is our greatest strength. You experience this paradox in your life too. Sometimes you feel very weak, very helpless. You think you're being crushed by life's difficulties, but then you find that strength within you, the strength to understand problems, to create solutions, to ask for help, and to get back up again. We are a fragile, but also an incredibly resilient species, and Artemis II combined these two truths in that single window. That fragile blue ball was also the genius that built and sent that capsule there. And this brings us to the fifth and final paradox, the paradox of danger and beauty. The moon is beautiful. That silver disk in the night sky has inspired poets, lovers and dreamers for thousands of years. But as Artemis II showed us, the moon is also an incredibly dangerous place. That surface is constantly being battered by meteors striking at speeds up to 160,000 kilometers per hour. Those 6 explosions, those 6 flashes seen during that 7-hour flyby, were just a small proof of this brutal reality. No atmosphere, no shield, just a naked, relentless bombardment, and in that silence, the cosmic rays passing through their heads. Each flash was evidence of a micro-bullet damaging their DNAs, slowly eroding their bodies. This is the tragic truth of the universe. It is not only beautiful and magnificent, but also cruel and indifferent. The universe has no intention of killing you, but it also has no intention of keeping you alive. It just is, and its rules are completely indifferent to our existence. But, one of the strangest and most wonderful qualities of the human spirit is the ability to find beauty precisely within this danger. The astronauts were not terrified when they saw those explosions. No, they watched in awe. Surreal, they said. Those cosmic ray flashes were a biological hazard, but also a direct contact, a personal experience with the most fundamental particles of the universe, and that 57-minute eclipse. That moment was a moment of both absolute danger and absolute beauty. In the midst of a star's radiation storm, protected only by a thin sheet of metal, they witnessed one of the most magnificent spectacles in the universe. This is the great paradox. Beauty is often found on the sharpest edge of danger. The brightest flowers grow on the steepest slopes. The deepest loves carry the greatest risk of heartbreak. You know this too. The most meaningful, most beautiful moments in your life are often the ones where you took a risk, where you stepped out of your comfort zone. The Artemis II crew took that ultimate risk. And in return, they experienced the ultimate beauty. They reminded us that the universe is both dangerous and beautiful, and that these two cannot be separated. And perhaps the meaning of life is to find the courage to walk that sharp line between the two. All these paradoxes, these contrasts, these deep thoughts. How do you feel now, after learning them? On one hand, is it that deep, existential awe, and perhaps a bit of sadness we feel in the face of the universe's vastness and our own smallness? Or on the other hand, is it that jubilant admiration and hope for this incredible human mind and spirit that can understand this universe, witness its beauty, and even be a part of it? The answer is probably both, and that's okay. Because the greatest lesson of Artemis II is perhaps this: the universe is too complex and wonderful to be contained in simple answers. It can be simultaneously tragic and beautiful, lonely and connected, transient and eternal. And we are the curious beings, standing right in the middle of this complexity, trying to understand it all. This journey showed us that our place in the universe is not a fixed point, but a constant negotiation, a dance of question and answer. Every discovery gives birth to a new mystery. Every moment touches eternity. Every human is both fragile and incredibly strong. Distance, time, knowledge, fragility, and danger. The journey behind the moon has forever changed our understanding of these fundamental concepts. We now know that the farthest distance can create the deepest bond. Alas, the shortest moment can carry the greatest meaning. When we know the most, we understand how little we know. When we are most fragile, we can be the strongest, and in the greatest danger, we can find the purest beauty. These are the philosophical truths Artemis II whispered to us. But is this journey over? Are these thoughts a final point, or a new beginning? Because, after understanding all these paradoxes, one more question arises in our minds, a more personal, a more profound question. How did this experience change just those 4 astronauts? And what does that change tell us about the future of being human? Because this journey also has an inner dimension, and that inner journey was perhaps the most important discovery made behind the moon. Because that metal capsule travelled not only in space, but also in the depths of the human soul. Now, we're going from the outermost layer to the innermost, to the very core. It is time to understand what this journey meant for those 4 people as individuals, and what their personal transformation signifies for us, for humanity. This is not just the question, what is our place in the universe? But the question, who are we in this universe? And the answer to this question, once again, appears with a series of poignant and enlightening paradoxes. The first of these is the paradox of individual experience and universal meaning. On one hand, there is the extremely personal, unique experience of 4 people, that overwhelming feeling Christina Koch felt while looking out that window, that indescribable grief and pride Reed Wiseman experienced when he heard his wife's name, that moment of enlightenment for Victor Glover, when he saw the Earth as a single whole, and that sense of historical responsibility Jeremy Hansen felt when that record was broken. These moments are theirs, only theirs. No one, no matter how much they empathize, can ever know exactly what was in their hearts at that moment, which neurons fired in their brains. This is the most fundamental and tragic truth of human existence. We are lonely beings, trapped inside our own consciousness. Our experiences, no matter how much we describe them, are ultimately our own. They can be shared, but never fully transferred. Those 4 people, even while witnessing one of the most magnificent sights in the universe, were actually alone at the peak of that experience. But, The magic of the story lies precisely in how this individuality transforms into universal meaning. That extremely personal carol moment became a universal story of grief and love that touched the hearts of millions. Those 4 astronauts, unlike Apollo, were of different genders, different races, different nationalities. They were not just 4 individuals, but a microcosm of the human family. And that is why their personal experience became our collective experience. They were there on our behalf. They looked with our eyes, they felt with our hearts. This is the great paradox. The most personal is also the most universal. You experience this in your own life. And you think your deepest pains, your greatest joys, your most embarrassing moments are yours alone. But then you share your story, and you see a recognition, an understanding in the other person's eyes. Me too, they say. I felt that too. And in that moment, the walls of loneliness crumble. Artemis II reminded us that our individual stories are the threads that connect us to one another. You too, with your own unique story, are part of that great tapestry of humanity. The second paradox is the paradox of silence and sound. On one hand, there is that 40-minute absolute overwhelming silence. The moment when communication was completely cut off, when the only link between them and Earth was the mathematics they trusted. This was not just radio silence. This was an existential silence. The deafening sound of the universe's indifference, the depth of the void. This silence could have been a source of fear, a moment of despair, a tragic moment that reminds you how small and insignificant a cog you are in that giant cosmic machine. In that silence, even a scream would be lost in the void. It was to face the reality that existence could be erased in an instant, a place unreachable by all the noise, all the music, all the conversations of humanity. But, from within that very silence, the most powerful, most meaningful voices of the mission were born. Because that silence was not an emptiness, but a space for purification. A mind cleansed of the noise of the world, its expectations, its distractions, sees more clearly, feels more deeply. In that silence, the astronauts saw the true colors of the far side of the moon. They witnessed 2 impact flashes, and they experienced that indescribable relief and awe they felt when they saw the Earth rise again from the horizon. So, when communication was re-established, their voices were no longer just the voices of professionals transferring data. They were the voices of witnesses, voices filled with the wisdom of that silence, the weight of that void. This is the great paradox. A meaningful sound often arises from a deep silence. An artist's best work emerges in the silence of their studio. A writer's most powerful words are shaped in their solitude. You know this too. It's hard to hear your own voice in the noise of life. But when you create those quiet moments for yourself, when you meditate, when you walk alone in nature, your thoughts become clear. You understand better what you want, who you are. Artemis II reminded us that silence is not an absence, but a potential, and that our most powerful messages often come from our quietest moments. You too can find your own voice in your own silence. The third and final inner paradox is the weight of the past and the call of the future. On one hand, there was the ghost of Apollo, permeating every moment of the mission. Jim Lovell's voice, the Apollo 8 mission patch, the Apollo 13 record. This was that melancholic, tragic feeling of returning to a place we had reached half a century ago, only after a 53-year gap. This was also an acceptance of lost time, of deferred dreams, a nostalgia for the golden age of the past, as if instead of taking a giant leap forward, we were just following our own footsteps from the past. This was a reminder of how slow and difficult progress can be, and proof that the past can sometimes stand like a shadow over the future. But, the Artemis II mission showed that the past can be a foundation, not a shadow. It was a launch pad, not a prison. Jim Lovell's voice was a blessing, not a lament. When he said, "Enjoy the view," he was actually saying, take this legacy and carry it further. And that challenge Jeremy Hansen made when the record was broken was the pinnacle of this philosophy. Ensure that this record does not stand for long. This is not a rejection of the past. This is the greatest honor that can be paid to the past. It's saying, what you did was so valuable that we have to build upon it, to go higher. and this mission honoured the legacy of Apollo by diversifying it. Christina Koch, a woman, Victor Glover, a black man, Jeremy Hansen, a Canadian. This was the harbinger of a more inclusive future that went beyond the homogeneous world of Apollo. This is the great paradox. We often take the most solid steps into the future by paying the deepest respect to the past. You too can see your own past as a burden. The mistakes you've made, the disappointments you've had, but they are also your teachers. They are the experiences that made you who you are. The best way to honour your past is not to live in it, but to build your future by learning from it. Your life too is a bridge between who you are and who you will become. And Artemis 2 showed us that it is possible to build that bridge solidly. The individual and the universe, silence and sound, the past and the future. These inner journeys change those 4 astronauts forever. But this change doesn't just belong to them. This change is offered to all of us as a possibility. Because off this mission gave us a new language not just about the moon, but about what it means to be human. But at the end of all this philosophical depth, one question still remains unanswered. A practical, concrete, and forward-looking question. All these experiences, all these lessons, all these paradoxes, what do they give us to take the next step? What is the ultimate lesson we take from this journey, and how does that lesson prepare us for humanity's next great adventure? And that lesson is perhaps the most unexpected, most profound gift of this entire journey. Because this experience taught those 4 people, and therefore all of us, the delicate balance between action and acceptance. This is perhaps the hardest lesson to learn, but it is the most important. This is the ultimate wisdom that will prepare us for humanity's next great adventure. And this wisdom is also illuminated by a series of final, deepening paradoxes. The first of these is the paradox of purpose and purposelessness. On one hand, there is the unstoppable purposefulness of the human species. We are a species that sets goals, makes plans, solves problems. The Artemis 2 mission is a masterpiece of this purposefulness. And tens of thousands of people worked for over a decade for a single goal, to send 4 people to the moon and bring them back safely. Every screw, every line of code, every orbital calculation, all served this great purpose. This is the purest form of human intelligence and will. We say, we will do something, and we do it. This is what makes us a species that moves mountains, crosses oceans, and reaches for the stars. This is our tragic and at the same time glorious destiny, to always seek the next peak, the next goal. But, when that capsule reached lunar orbit, when that goal was achieved, the astronauts faced a completely different reality. The universe itself has no purpose. Those 6 meteor impacts did not serve a purpose. They just happened. The moon being two-faced was not part of a plan. It was just a chemical coincidence. The universe is completely indifferent to our projects, our goals, our dreams. This is the most shattering truth of humanity's place in the universe. We, as meaning-making machines, live in a fundamentally meaningless universe, and this can lead to a deep sense of loneliness and purposelessness. But the beauty lies right here, because since the universe does not give us a purpose, we are free to create our own. This is the great paradox. In a purposeless universe, our greatest power is our ability to create our own purpose. Those 4 astronauts brought their own meaning into that purposeless void. They did science, broke records, cried, laughed, and named a crater Carol. They filled that cold, indifferent landscape with human warmth. You experience this paradox in your own life too, and sometimes life can seem meaningless, your efforts futile. But then, you create your own small purposes, to build a family, to create a work of art, to help someone, to grow a garden. These are not purposes the universe gives you. These are the gifts you give to the universe. And Artemis 2 reminded us that our greatest achievement is to create our own small, more precious islands of meaning in that vast purposelessness. The second paradox is the paradox of difference and unity. On one hand, there is the wonderful diversity represented by the Artemis 2 crew. A woman, a black man, a Canadian, an American. Different backgrounds, different cultures, different life experiences. This was a very different picture from the homogeneity of the Apollo era. And these differences were not just symbolic. They added richness to the mission itself, different perspectives, different observational skills, different problem-solving approaches. Victor Glover summarized that diversity perfectly. We do great things, not when we put our differences aside, but when we bring our differences together. This is the most fundamental truth of the 21st century. Diversity is not a weakness but a strength. But when that capsule reached its farthest point, that diversity melted into a much deeper unity. When they looked out the window, they were no longer a woman, a black man, a Canadian, an American. They were 4 Earthlings from that little blue planet. In that moment, all the labels, all the identities that separated them, lost their meaning in that overwhelming shared experience. They were a team for humanity. This is the great paradox. True unity is found not by erasing differences, but by transcending them. What unites us is not that we are all the same, but that we all share that same small, fragile planet. You experience this paradox in your own life too. You come together with people of different beliefs, different opinions, different lifestyles, and these differences can sometimes lead to conflicts, disagreements. But then you face a common threat, a common joy, a common loss, and you realize how insignificant those differences are. And you rediscover that fundamental humanity that unites you. Artemis II reminded us that we don't need to wait for a disaster to find that common ground. That overview effect. It showed that just looking up, changing our perspective, can be enough. You too are a part of that unity. And that unity is even stronger, not despite your differences, but with them. And this brings us to the final philosophical thought, the ultimate lesson of this journey, the paradox of returning home and moving forward. On one hand, there is the instinct to return home. At the end of that 10-day mission, after all the records, all the discoveries, the greatest goal was to return home. That simple but powerful gesture of the mission controllers in Houston, flipping their patches over, summed it all up. We are ready to bring you home. This is the most fundamental, most primal human desire. To be safe, to be in a familiar place, to be with loved ones. That blue planet was not just a piece of rock. It was home, and returning to that home was the sweetest victory of the journey. This is a tragic and at the same time beautiful truth of human nature. No matter how far we go, a part of us always wants to return home. But, at the same time, there is the urge to move forward, to explore, to reach for the unknown. Jeremy Hansen's challenge: ensure that this record does not stand for long. Jim Lovell's voice. When he said, enjoy the view, he was actually saying, expand this view for the next generation. This is the great paradox. Humanity is a species that wants to stay connected to its roots and open its wings at the same time. We want both to belong to a home and to wonder about the world beyond that home, and the entire Artemis program is built on this paradox. Artemis II was a rehearsal for a safe return home, but Artemis III will be the first step to landing and staying on the surface. Artemis IV will move that home to lunar orbit, and after that, Mars. You experience this tension in your own life too. On one hand, there is the comfort of your comfort zone, your habits, your safe harbor. But on the other hand, there is the desire to try something new, to take risks, to improve yourself. And the art of life is to strike a balance between these two, not to go so far as to forget your roots, nor to stay at home so long that your wings atrophy. Artemis II perfectly symbolized this balance. It was a return, but it was also the beginning of a much greater leap forward. Distance and closeness, time and the moment, knowledge and mystery, fragility and strength, danger and beauty, the individual and the universe, silence and sound, the past and the future, purpose and purposelessness, difference and unity. And finally, returning home and moving forward. This philosophical journey has given us profound lessons about the universe and ourselves. This journey is now coming to an end, but in reality, everything is just beginning. Because Artemis II is not an end, but a beginning, not a destination, but an invitation. Those 4 people did not just see rocks and craters behind the moon. They opened a window to the future of humanity. And what we saw through that window is both frightening and incredibly hopeful. Now, at the end of this long journey, it is time to put all these pieces together and understand that final, most important message we brought back from behind the moon. On this journey, We saw the dark side of the moon, but there's something I didn't tell you. The universe itself is also under the control of a dark force. Its name is dark energy, and this energy is not just expanding the voids, it is slowly tearing the universe apart. On our next journey, we will witness the final victory of this cosmic force. Are you ready?